enjoy the transmitters and receivers?
Oh gosh, it got really close.
It's on video.
So, if yours goes, mine goes too.
Okay, this here's a 34-meter beam wave guide. It's a beam wave guide because it's got that large tube that reflects the RF energy from the subreflector in a hole and bounces them off a series of mirrors and directs all that RF energy down into the pedestal that you just came from. And that then RF energy gets bounced off another mirror and into one of those RF packages. This is an azimuth and elevation type antenna. It goes to azimuth and elevation. The one behind you over here is an XY. That moves in an XY condition. And then the one over at Echo that you saw, that's where we were today, that is an hour angle and declination. I like azimuth because it's real easy for me to figure out 0 to 360 and 0 to 90. It's pretty easy for me. I can do that. This is also an electric drive. It has 4 motors, 2 on one wheel, 2 on another wheel. Then you have the 2 idler wheels. We keep our pointing very accurate because we use a thing called counter torque where we wrap up where we use the opposing motors, we wrap up all the slop in the gearbox. So we don't get any bouncing in the gearbox. And then we'll do a torque between the 2 drive motors, the 2 drive wheels, to get any kind of slop out of that. So that gives us a real stable platform so we can point accurately at a spacecraft. And it still amazes me how we can take a hunk of steel like this and point it at something that is way out, Pluto, without, and still get that signal back. It just amazes me that we can do that with steel.
How many crew run this?
I'm sorry?
Crew. How many crew? Are there just one person that runs this? Or?
No, we generally work in pairs. Right, and so when this one's down for maintenance, then we'll have a couple of guys on the mechanical side. We may have some RF, radio frequency guys working down on the pedestal, etc.
But when it's running day to day, there's 2 people running.
There's nobody here during the day.
No, you're talking the operators, the one who point and whatever. It takes one person to
They're from SBC 10. You'll see them on the next shot. They're at SBC 10.
So this is really unmanned.
Right.
Wow.
Effectively, it's unmanned. Now the neat thing about this is that there aren't a lot of cables that go up the structure because most of the signal processing is done downstairs, and so we only have things like up at the top of the apex. We've got the power to go to the motors that actually drive our subreflector because we have a movable subreflector. And of course, then you need feedback from that to send that down to our positioning. We have drive motors on the elevation bearings. We have to power those and get feedback for those tachometers. And everything goes through a cable wrap, which you can see looks like a bicycle chain. It's right there in the middle. And that allows the antenna to go plus or minus 270 degrees without tearing out the cables. And you saw it over in the museum, you also saw a pintle bearing. The pintle bearing is actually the interface between the haunch, the little haunch in the middle, and the actual rotating antenna. So that sits right there in that interface.
Does where it's pointing give you a tip what it's listening to? Like if it's straight up, is that something?
Yeah, straight up is sky. That's what we call it. We call it sky.
Sky.
Yeah. And they'll take it and they'll take noise measurements at the sky, and they'll know what they can then utilize their system temperature measurements at that point.
And you do that primarily at night when there is no sun, because the sun effect will heat up, provide additional noise. So you try to point to a known star.
So the sun would affect the radio signal coming?
Yeah. Temperature does have some effect. It's noise.
What happens when there's an earthquake?
The ground shakes, and then we tell everybody stop tracking, and then we will, if it's off shift, we will bring people in. They will inspect the antennas. Now this is one that we feel significant. If it's a significant shake, we'll make sure they come out before we move the antennas. we will have them inspected, visually inspected. We did have the, if you guys remember the Landers quake, Big Bear quake, we actually tore the subreflector off of the 70-meter antenna. And that took us, if I remember right, 6 months to put it back, Jeff? About 6 months to get it back online. So, yeah, whenever there's an earthquake, we just stop the tracking. Now, if it's just a little, then we just generally go on. Yeah, we will go have guys take a look, but we generally go.
Regarding your question earlier, unmanned or whatever, they are all manned, but it's remotely operated. They don't make decisions, they don't point themselves. Unmanned, that's the meaning of it. You know, they're automated.